The Canadian tundra near the Arctic Circle is a vast, remote, hostile, and delicate environment. Here, geologists discovered beneath glacial lakes deposits of ancient volcanic rock uplifted from deep in the earth, where heat and pressure, eons ago, created diamonds. To recover these precious gemstones, Diavik, in conjunction with native peoples, invested huge financial and engineering resources to create a self-sustaining environment to recover these elusive gems.
The fact that we're putting rock through the plant, it's hard on everything.
We process kimberlite. It does wreak havoc on our equipment. It's very abrasive, so we shut down our plant every 2 weeks for maintenance and inspections.
The milestones, of course, are tonnage during a day and the number of carats that come out of the tail end of the plant, the recovery area.
Time is money. Interruptions in our process are costly.
The cost to the plant for an unscheduled shutdown, we do probably 30,000 carats in a day. That works out, the cost of those is about $200 US a carat. Now, when you calculate that out, an hour of production lost is about $200,000. So it's quite considerable to lose any production time.
The challenge to Diavik was not only to monitor and maintain its operations for increased throughput, but also to maintain a life-sustaining environment for its operators.
When we think of the size of this plant, we have about 4,800 I/O in the plant, and that's comprised of, well, we're a totally self-contained plant, or island, if you will. We've got a powerhouse, we've got a water treatment plant, we've got boilers, we've got the process plant. It's all tied together.
We are here under very strict regulation in all of our impact on the natural environment.
Diavik found the solution to these challenges in the DeltaV digital automation system, a part of the plant web architecture from Emerson Process Management.
Utilizing DeltaV, we've put in most of the modern bus technologies. We've got OSI-bus that we're using to communicate to discrete devices. We've got DeviceNet buses communicating to our motor starters. We've got the Profibus bus that we're using to communicate to variable speed drives. We've got serial interfaces that we've got PLCs communicating back to DeltaV. We're utilizing OPC as a communications system between two separate DeltaV systems. We're utilizing AMS to a certain extent and HART on some of the devices. Now, one of the buses we have has about 25 motors on it. And with that, if one of the motors fails, it's very simple to go in and find that motor. It'll come up with a big red X saying, I'm not communicating, and you can zero in on it within seconds.
The plant web architecture's use of bus technologies let Diavik save on implementation costs.
We make extensive use of all the available buses, Profibus, DeviceNet, OSI-bus, throughout the entire plant. All of our valves, all of our various drives and binary information all travel over buses. That way we have greatly reduced all of our initial wiring costs.
And the digital automation system's familiar graphic interface let Diavik save on operator training.
It took me a week to 2 weeks to learn the basics of the system.
For the first few months, my training was on the job.
Within a week, yeah, I was operating the plant.
DeltaV, I find it's user-friendly. I don't find it to be a challenge, and I find it very easy to bring another operator when I'm in charge of training other people.
But we do have a simulator, trainer simulator, that we're using to introduce our newcomers to the control system. We also use that simulator to develop new strategies to be implemented in our live process.
Diavik capitalized on the digital automation system's enriched process information and history to improve its process.
With the DeltaV system, with us getting more familiar with the system and knowing how to use it, and the trends and the analogs that we could use to database all the presents that's happening, it's very much so helped us as far as preventive maintenance.
We use the DeltaV to look at the history of a piece of equipment, and it helps us develop our future predictive maintenance and preventative maintenance program.
The enriched process information allowed Diavik to better diagnose the condition of its process equipment for improved troubleshooting.
To utilize the system as a tool for troubleshooting, it's been tremendous. Now, you don't necessarily need to go out to the actual devices to do much of the troubleshooting anymore. You can pretty much do it from a console looking at the control system. DeltaV Explorer and diagnostics that's embedded within DeltaV has been tremendous in troubleshooting, solving problems.
Part of the control system involves interlocks, so that when something occurs where you have a trouble occurrence in the plant, that you can actually have an interlock that will protect equipment that's upstream of the piece of equipment that's having a problem.
The instrumentation department has set up as allowing different intervals for different kickouts. If you get a thermal, well, it's going to give, I believe it's a 5-minute or a 30-minute or an hour interlock where you're not allowed to start up that piece of equipment because it's registering that your RTDs, your bearing temperatures are like too high. So if that point wasn't there, if I could just go in and start up a piece of equipment, well, we all know in this room it's going to fry and it's going to cost millions of dollars.
Using DeltaV and DeviceNet has allowed us to avoid a lot of unscheduled shutdowns. There's a lot of diagnostic data that we have that we're able to collect from the motors and prevent any unscheduled shutdowns. Absolutely.
Information coming out of the multilin is all available at the fingertip via the standard interface that we're using, and it has greatly helped in troubleshooting.
DeltaV helps us turn reactive maintenance into predictive maintenance.
For Diavik, the result of improved diagnostics and predictive maintenance is improved throughput.
Over the last 6 months, we have dramatically improved our tonnage throughput, and it has been fairly painless.
The increase through the throughput through DeltaV as far as cost production is basically double. As far as numbers, it's hard to describe. I don't have numbers. But as far as production-wise, basically just if you have $1 bill and you double it, that's $2, right? So that's basically what DeltaV has been helping us do.
But as it stands right now, we went from running about 2,000 tons a day to 4,000. Then we projected that we could do 8,000 without adversely affecting the process, which we reached and surpassed within the last month or so.
Diamond quality coming out of the end of the plant. Average production is about 30,000 carats in a day. We've had some record days back in the summer of '04, where we've done about 90,000 carats in a day.
From these production gains, Diavik plans to continue automating its process.
We have a drying system to dry our material, our processed material. This has always been the bottleneck in all of our system. As it stands right now, we do have a temperature and a gate position being fed into the DeltaV. The only thing needs to be done at this point is to automate the whole process. We expect to see a major improvement within the efficiency of the dryer itself in the order probably of about 10%.
As far as the future direction of the plant goes, we're looking at expanding on the bus technology that we have within DeltaV. We want to monitor some of the water flows, so we've got 6 mag meters that are going to be installed shortly. They're all in a central area, so we can use the foundation field bus to do that. So we're all looking forward to doing that. It's going to give us another step in the direction of new technology.
Our next round of installation here, we do expect to implement field bus throughout all of our new equipment that we're buying, because we are very confident with all the bus systems. The information it comes back with, the ease of use, ease of troubleshooting, the ease of installation, it has proven itself very well here in the field at Diavik.
Another innovation that we're looking at here in the plant is in our recovery area. Recovery is, of course, where we find the diamonds. In there we have 10 X-ray machines that are using local computers within the X-ray machines. These are proprietary machines or proprietary computers, and they're causing us a considerable amount of trouble as far as maintenance on the computers, upgrades, etc. So we're going to bypass those altogether and bring the data directly into DeltaV, and it'll simplify things considerably.
Diavik's plans are to have a completely predictive and preventative maintenance program. We'd like to completely get rid of the reactive maintenance, and DeltaV is helping us achieve that.
The DeltaV, I think, is doing a very effective job here in giving us control that is very simple, it's logical, it's easy to see, and it's easy for the operators to control their plant using that tool.